Assalamu alaikum and good day, students. In this video, we will be covering a lesson topic on computer architecture. The lesson objectives are: 1. To know the structure of von Neumann architecture concept. 2. To describe the function of the computer buses. 3. To know the concept in the computer models that uses the computer registers. 4. To describe the functionality of these registers during the fetch and execute cycle. 5. To define the function of the control unit, the memory unit, arithmetic and logic unit in general. The computer architecture that we are going to learn was developed by a computer specialist, known as Mr. John Neumann. He had developed this architecture around the year 1945. His idea was to hold programs and data in a memory. From the memory, data would move between the memory unit and the processor. Next few slides, I will be explaining the details about the features involved in the computer architecture, as follows. Types of computer buses. Types of computer registers. The brain of the computer system, which is the CPU. The general function of memory unit. The general function of control unit. The general function of ALU, which is also known as arithmetic, logic unit. Last but not least, is the procedure involved in the process of fetch and execute cycle. You may refer your textbook. This chapter is covered in page 45 to page 49. First, what is the microprocessor? Microprocessor is also known as the central processing unit. CPU is the brain of the computer system. It contains the three major units for operation in the computer systems. The three units are the memory unit, the arithmetic and logic unit, and the control unit. Second, what is memory unit? Memory unit is made up of a number of partitions. Each cell has a unique address location, and inside it stored the content. Each address is using 8-bit. Each data content is using 8-bit. However, in the real memory unit, it is actually much larger than this. Some are using 16 bits or 32 bits and even 64 bits. The memory unit has two types. 1 is the read-only memory, and 2 is the random access memory. In this chapter, we will be talking about the function of RAM unit only. Third, what is control unit? One of the unit, found inside the microprocessor of a computer system. Its function is to control and monitors all the operation inside the computer system, including operation of memory, the input and output devices, and other processors unit like the ALU. What are the input units? The input units are those devices used to accept or input in data from users. These devices are like the keyboard, the mouse, the touchscreen device, the scanner, the sensors, the microphone, and so on. What are the output units? The output units are all devices used to display and output the results after processed by the computer system. Amongst examples of output units are the monitor, the screen, the printer, the projector, the speakers, and so on. Fourth, what is the arithmetic and logic unit? The ALU is one of the units found inside the microprocessor. Its function that carries out arithmetic and logic operations on the operands in computer instructions. Further in the lesson, we are going to discuss about the computer bus's architecture. Then, later, we covered on the uses of registers in the architecture. And finally, the process of fetch and execute cycle in the computer system. In this slide, we are going to discuss the computer architecture concept in using computer buses. Please turn over your textbook to page 45 and have a look at the diagram in figure 4.3. The diagram here is showing you the idea of how a processor and memory unit are linked together by connections known as buses. There are three different types of computer buses. First is address bus, second is data bus, and third is control bus. The flow of data between the processor and the memory, as well as to the input and output devices. In the table shown here, it's stated the functionality of the three buses. First, the address bus is used to carry signals relating to memory addresses. Second, the data bus is used to carry data relating to memory content. Third, the control bus is carrying signals relating to the monitoring and coordinating all activities within the computer system. The address bus is a unidirectional, a one-way direction from the processor to the memory unit, or from the processor to the input/output devices. The data bus is a bidirectional data flow. It is between processor and the memory unit, or processor and the input/output devices. The control bus could be either unidirectional as well as bidirectional. It will monitors the whole activities of data flow between the memory as well as the input and output devices. Next, we are going to discuss the concept of von Neumann architecture, whereby it is making use of the 5 registers inside the CPU for the manipulation of data content inside memory, under the monitoring of the control unit. Have a look at page 46. In figure 4.4. In the diagram, you will see how there are also illustrated with the use of the 3 buses. First, what is a register? In the CPU, there are basically 5 registers. A register is a high-speed storage area within the computer. All data must be represented in the register before it is processed, decoded and executed. The 5 types of registers are 1. Program counter or PC, 2. Memory address register or MAR, 3. Memory data register or MDR, 4. Current instruction register or CIR, and 5. The arithmetic logic unit or ALU. Here, I am also going to illustrate the CPU concept during fetch and execute cycle. You may refer your textbook on page 49. It is also illustrated in figure 4.9. What does the term fetch means? The process of fetching means a single instruction or data needs to be retrieved or take out from the memory unit where it is currently stored. The process of fetching is done by the register called program counter. What does the term execute means? The process of execution is data from the memory is successfully decoded, which means, from a raw data, now it becomes a decoded data in which an instruction a computer understands. This instruction will either needs to be executed in the ALU, or to the output devices. Let's elaborate this procedure further. Let's take several examples, for a clear illustration about fetch and execute cycle, in this slide. An illustration of how the 5 registers are used during the fetch and execute cycle in the CPU. Example 1. Let's assume a read operation, taking the content from the memory location 11110001. Step 1. The PC register is fetching the address 11110001. Step 2. The address in PC is copied to the register MAR, that is the memory address register. This is done by the signal sent by the address bus. Step 3. The control bus will send a read signal. In step 3, the content will be read, located in the address 11110001. The content will be put into the register MDR, or the memory data register. Step 4. The content in the MDR is now copied into the register CIR. This is done through the data bus. Step 5. Automatically, the control bus will send a signal for the PC register to be incremented into 1 to get the next instruction. Step 6. Instruction in the I.R. is finally decoded and executed by sending out signals by the control bus to various components of the computer system. I am going to illustrate another example. To understand better, let's take example 2. Let's us consider a write operation. Here, the data content of 0101, 0101 is written into the memory location 00001111. Step 1. First, the data content in CIR will be placed inside MDR. Step 2. The control bus will initiate a write signal for an empty location from the memory fetched by PC, which is ready in the MAR. Step 3. The content of MDR is now placed inside the memory as located inside 11110000 of MAR. The procedure is much simpler here. As a closure of this lesson, your teacher, Hazika, will assign you with several activities to enhance your understanding about this chapter. Best of luck, students.